Welcome back. Today we will be graphing polynomials in factored form. We'll do problems 1 and 2 from the homework. We will do all of problem 1 and just the first one from number 2 so you can get a feel for how we are going to write these functions. Alright, let's begin. So we're asked to graph the polynomial y equals x times x plus 3 whole squared times x minus 1. It looks a little bit daunting at first, but keep in mind our first step. We want to find our x-intercepts. If we can find our x-intercepts, then we've got half of the graph done. So remember, to find your x-intercepts, we always need to set the function, set y, or set f of x equal to 0. So let's do that here. I'm going to set my function equal to 0. And because of the zero product property, from that I can take each factor and set it equal to 0. This gives me x equals 0 as one of my intercepts, x equals negative 3 as one of my intercepts, and x equals positive 1. So in total then I have 3 x-intercepts. And it's also useful to note that if you can count the number of x's that you see, here I see 1, 2, 3 x's, that's how many x-intercepts you should have. So here they are, all 3 of them. Okay, immediately after finding our x-intercepts, we're going to plot them. So find x-intercepts and plot on the graph. Let's do it. So at x equals 0, at x equals negative 3, and we'll label it because it's helpful, and also at x equals 1. Alright. Now we have to figure out where this graph is above the axis and where it's below the axis. So our graph could look like this. Okay? Could also look totally different. Yet still, it could never even cross. It could just keep bouncing off. So we need to figure out where this graph is going to be above. And when I say above, I'm going to use the word positive. Because if our function is positive, it means it's above the x-axis. In this case, it's positive for all of these intervals. Okay? It's just an example to show you what I mean by positive and negative. But we're going to be putting down these signs ourselves. So notice here that I have 4 intervals to deal with. I have this interval here to the right of 1. I'm either above the graph, above the axis, or below. Between 0 and 1, I will either be above or below the axis, positive or negative. Between negative 3 and 0, I'll be positive or negative. And then over here at the end, I'll be positive or negative. So we're going to put down 4 signs to tell us where the graph is located. Okay, so first, we're always going to start at the rightmost side. So we're always going to start here. So to determine if we're above the axis, like this, or below the axis, like this, we're going to look at the sign out in front. Okay, what's the sign there? Well, if you don't see a negative, that means it's automatically positive. So our step 2 is to place plus or minus signs to determine whether we're positive or negative, starting on the right. Using the sign in front. So since it was a positive out in front, that means that this interval, my graph is going to be above the axis. So I'm just going to put a plus sign. I'm positive. Okay, we've got that interval down. Now we need to figure out this little interval. So we're basically reading from right to left. We're going that way. So now for this interval between 0 and 1, I'll highlight it. We need to figure out positive or negative. Here's how we'll do that. Since we're crossing over this x-intercept, x equals 1, I want you to look at where we got x equals 1 from, right here. Now, look at the factor right above it that gave you x equals 1, and that's this factor, x minus 1. We're interested in the exponent of this factor. Since there is no exponent up here, for example, this one has an exponent of 2. right? This factor has an exponent of 2, but x minus 1 doesn't have an exponent. So when there is no exponent, you automatically will fill in a 1. Now, why is that important? Well, the exponents will tell us if we're going to flip the sign, so if I'm going to become negative, or if I'm going to keep the sign that was up here, so if I should stay positive. So let's see. If the exponent is even, we keep the same sign. If the exponent is odd, we flip the sign. In this case, at 1, I'm looking over here, and I'm noticing that my exponent is odd. That means I'm going to flip the sign. So here, between 0 and 1, I'm no longer positive, I'm going to be negative. I'm flipping it. Our next decision point, since we've figured out that a graph is negative here, or below the axis, our next decision point is to determine this interval, so we're crossing over the next x-intercept at 0. So as before, you're going to look to where you got x equals 0. Now observe the factor right above that. And we need to identify the exponent. Since there is no exponent here, that means we have a 1. 1 is an odd exponent, so we will flip that sign again. Instead of being negative this time, I'm going to become positive. Notice that I'm not talking about flipping the original sign. I'm talking about just flipping the previous sign. Since I'm on this interval now, I'm going to flip the sign from the interval right before it. Okay, we've got one more to go. Alright, last one. So this one was positive because we flipped it again. Okay, now we have to make a decision at -3. So go to where you got x equals -3. Look at the factor right above it. Our exponent is even. So when I have an even exponent, we keep the previous sign. Since in this case my previous sign is positive, I'm going to keep it positive just like that. Okay, so now we know where our graph is positive and where it's negative. Now we simply have to draw the graph. So let's follow the instructions, and we're always going to graph from right to left. So put your pencil down somewhere over here. It's either going to be up here or it's going to be down here. You just have to figure out whether you're putting your pencil down above or below the axis. Well, since my rightmost sign is positive, I know that I'm starting above the axis. And now let the x-intercept guide you. Go to the nearest x-intercept. Okay, at this x-intercept, we have to decide if we're going to cross below the axis or if we're going to just stay above the axis. Well, let the sign guide you. Since it's negative, that means we have to dip below the axis, right? And then come up to the next x-intercept, which is at 0. Now we're going to be between 0 and -3. We're going to be above the axis because it says we're positive. And then touch the nearest x-intercept. And now to the left of -3, we're going to be above the axis again. So now it's time to determine. So we've drawn our graph. It looks beautiful. Seriously, like this is an awesome graph. We can make it maybe a little more curvy. There we go. Now we need to determine our end behavior. So let's write as x approaches -infinity, that's these values here on the left. Is our graph going up or down? Well, since it's approaching positive, it's going in the upwards direction. We'll write y approaches positive infinity. It's going towards the positive y values. Similarly, as x approaches positive infinity, that's these values way on the right, how is our graph behaving at the right end? Well, it's also going towards positive infinity. And there you have it. We've fully finished number 1A. It was kind of slow because I'm explaining every step to you, but the next one should go much faster. Alright, problem 1B. So we need to graph this. Step 1 says, find your x-intercepts. How do we do that? Well, we'll always set the function equal to 0. Now last time I said you should be able to tell how many x-intercepts there are by counting the x's. In this case, we have 1, 2 x's, so we'll only have 2 x-intercepts. This 2 out in front doesn't actually matter. However, if it was 2x, then we would have a third x-intercept. But since there's no x there, we can really just ignore that 2. It doesn't matter for our purposes today. So let's find our x-intercepts. We have at x equals 1 and at x equals -4. And now we're going to plot them. Go to x equals 1, x equals -4. And now all we have to do, step 2, so that was step 1, step 2, is put our pluses and minuses starting on the right side. Okay, so in this case I have 1, 2, 3 intervals. So I'm going to have 3 signs, but we're going to start on the right side. So, is this going to be positive or is it going to be negative? We'll look at the sign out in front. Since there's no negative there, that means that we must be positive. That means that the sign out in front is positive. So we'll put a plus sign. That's how we always start. Okay? Get it from the sign in front of the function. Next, we're crossing over the x-intercept 1. So go to where you got x equals 1. Look at the exponent for that factor, which is a 2. So notice that I don't care about 1 being even or odd. I don't care about that. It's the exponents. If it's even, we keep the same sign. If it's odd, we'll flip the sign. So the exponent is even. That means I'm going to keep the sign. So since this one was positive, my next interval will also be positive. Now we have a decision to make at -4. So look at where you got x equals -4. Go to the factor. The exponent, since there isn't one, is a 1. Since that's odd, I'm going to flip the previous sign. So since my previous sign was positive, my new sign will be negative. And now it's time to just connect the dots. So let's start positive on the right side. That means you're going to be above the axis. Okay. Touch the nearest x-intercept. And now between 1 and -4 over here, we're going to be above the axis still. So we don't cross over, we just kind of bounce. And now at -4, to the left, we need to be negative or below the axis. So we must cross down. And that's our lovely graph. Let's do our end behavior now. As x approaches -infinity, and as x approaches +infinity, how does y behave? Well, as x approaches -infinity, that's over here on the left side. Our graph is going down. That means y approaches -infinity. Now as x approaches +infinity, that's over here on the right side. Our graph is going up. So that means y approaches +infinity. And we're done. Let's do one more. Okay, problem 1c. So we're going to graph and then do our end behavior. So step 1, what do we always find first? X-intercepts. How do we find it? By setting the function equal to 0. So let's go. Question for you, how many x-intercepts will we have? If you said 3, you'd be correct, because I see 1, 2, 3 x's. So they will be at x equals 0, and I got that by setting this equal to 0 in my head, really. My next x-intercept is x equals 2, and I got that by doing x minus 2 equals 0, adding 2 to both sides. And then my last one is x equals -1. Right now we're ready to plot. So at x equals 0, at x equals 2, at x equals -1. Our next step is to put pluses and minuses starting on the right side. Okay, so we need to determine, is this interval here positive or negative? So we look for the sign out in front. Oh my gosh, this is our first negative. So immediately we know we have to put a negative there. It always will match the sign out in front. Now we have a decision to make. We're going to either keep or flip our sign at x equals 2. So go to where you got x equals 2, go to the factor right above it, and we're interested in the exponent. The exponent is odd, and odd means flip. We have a new decision to make at 0, so go to x equals 0, go to the factor above it. The exponent is even, and that means we're going to stay. We're going to keep our previous sign. New decision at -1. So go to where you got x equals -1, go to the factor above it, and the exponent is another 1, which is odd. Odd means flip. So I'm going to flip the positive. It'll become a negative as I move from right to left. It's time to draw our graph. Starting below the axis on the rightmost side, touching the nearest x-intercept, and now we have to go above the graph. Above the x-axis. Touch at 0, again, above the x-axis. Touch again, and now we're dipping below. So polynomials they don't have bounces like that. So in the last step, we should probably smooth out our curve. Just like that. Nice. So let's finish with our end behavior. As x approaches positive infinity, and as x approaches negative infinity. So I switched it up this time. As x approaches positive infinity, that means we're looking at the right side. Since our graph is going down, actually it's going down in both sides, so we'll put y approaches negative infinity on both sides. Alright, final problem of the day. We're asked to come up with a function that could represent this graph on the left. Now there is no single right answer for this problem. Okay? But there are wrong answers. So we're going to start this process by first identifying our x-intercepts. So I have an x-intercept at x equals -1, at x equals 3, and at x equals -4. So I'm going to go ahead and write those down for myself over here on the right side. Now if there's a plane, okay. Now if those are my x-intercepts, think about the factors those should have come from. If I have x equals -4, that means my factor would have been x plus 4. If I have x equals -1, that means my factor would have been x plus 1. Right, we're flipping the sign. If I have x equals 3, that means my factor was x, not positive 3, but minus 3. And so that's our first step, is to get our factors from our, is to get your factors, right, from the x-intercepts. And remember to always flip those signs. Our next step is to now observe the behavior at each value. So notice that at x equals 3, we're actually crossing the axis. We're going from positive to negative. We're from being above the axis to being below the axis. So if we had a sign flip like that, well, does that mean we had an odd exponent or an even exponent? We're crossing, so we're flipping from positive to negative. That's how odd exponents behave. So at x equals 3, or at the factor x minus 3, we need to put an odd exponent there. You could put a 1. You could put an 11. You could put a 21. You could put a 5. It doesn't matter as long as it's odd. You know what? I'm going to go ahead and put a 3, like a cubic, because 3 is an odd number. But honestly, if you put a 1, that's fine too, and you don't even have to mention it, because if there is no exponent at all, that means there's a 1. So you could leave it just like that, and we're good. Now let's go look at x equals -1. So on the left side of x equals -1, we're below the axis. We're negative. On the right side, we're also below the axis. So whenever it bounces off like this, it doesn't actually cross over. That means that we have an even exponent because our signs stayed on both sides. So at x plus 1, I know I need to have an even exponent, like a 2, a 4, a 6, an 8, whatever. I'm going to put a 2. Now we have one last decision to make at x equals -4. So we're going to go to that factor. Since it's crossing the axis, that means that my sign's flipped. That means I have an odd exponent. So odd exponents are where we cross, and even exponents are where we bounce, basically. So if I need an odd exponent, maybe I'll put a 3 here. So our second step was to choose our exponents. It doesn't matter what our exponents are, but they have to be either even or odd, depending on the behavior of the graph at that point. Our final step is to make sure that we're positive or negative in front. So here's what I mean. Remember how we always determine our very first sign over on the right side based on the sign out in front? Well, we need to make sure that those signs really match, right? If on the very right side I am below the axis, then there should be a minus sign out in front. Now in this case, we're not below the axis, we're actually above the axis, okay, because my graph is up here on the rightmost endpoint. So that means that there should be a positive out in front. Well, by not putting anything at all, that implies that there is a positive in front, so that means we're good to go. I could even do this. So all I've done now is I've added a 5 in front. Again, since there is no x next to that 5, that number doesn't even matter. It just matters that it's a positive 5, which it is. So this could also be a right answer. Either of these. Okay, you could put any number in front, it doesn't matter. I just care about the sign being positive. I hope that was helpful for you.